graph of this. Of course, with these decimals, it's kind of hard to position things, but are y'all all right with these x and y intercepts? Okay. All right, we're going to need to talk a little bit more about lines, so I need to start giving you a couple of formulas, and then we'll get into some other things. Oh. All right. Is everybody here having an opportunity to enjoy their summer a little bit? Yeah. Everybody okay with the weather? Too hot?
Rain.
I heard about rain. I don't believe it.
Yeah.
No. All right. So now, when it comes to lines, we have some standard formulas everyone should be comfortable with. Y equals mx plus b. This is called the slope-intercept form of a line. So in other words, if you have an equation that has x and y in it, the variables x and y, and then there's a number in front of x and then some number by itself, and we have solved for y, then that's called slope-intercept form. A specific example of this would be something like y equals negative 2x plus 5. That's a line in slope-intercept form. Now, the slope in this particular problem would be what? The number in front of x, which would be negative 2. That's your m, and that's your slope. And then this number 5, positive 5, would be your b in the problem, right? B is positive 5. And that is the intercept. Which intercept is it? The x or the y? It's the y-intercept. This is your y-intercept. Now, slope is defined to be the rise divided by the run. Now, if you've never heard that before, you're like, what? So I want to make sure. Is everyone comfortable with the idea of rise over run? Anyone need clarification on it? Yes, no? Don't be afraid. I'm going to clarify a little bit. Okay, so the way that I would go about graphing this line is I do not have to go find the x and y intercept like we just did. What I could do instead is draw my graph, start with the y-intercept. Always start with the y-intercept. So I'm going to go to 5, 1, 2, 3, 4, 5 on the y-axis, and I'm going to put a dot here. Okay, that was given to me by this number right here. It will always be that way. Whatever that number is, you go there on the y-axis, draw a dot. Now, all I need is one other point on the line. So how do I get to that other point? I use the slope, right? I use this number negative 2. But negative 2 is supposed to be the rise divided by the run, so I need to rewrite negative 2 as a fraction. So I'm going to rewrite it as negative 2 over 1. Is that still the same thing? So this says that as I'm standing on a point, to go to another point, I need to rise by negative 2 and run by 1. So rise is the up and down, and the run is the left and right. So if I tell you, hey, go up by negative 2, you're actually going to do what? You're going to go down 2. So I need to move down 2, and then I need to run, which is left and right, by 1. And which direction is that? Right. To the right. So if it's positive, you go to the right. If it's negative, you go to the left. So I'm just going to go down 2, over 1, and draw a dot. And once I have two dots, straight line, draw it, and you have the graph. So there's something very nice about this slope-intercept form of a line, and that's you can graph it quickly. Do you all agree with that? Okay. So that's the slope-intercept form. There's some other forms that you should be aware of. Y equals B. Let me give you an example first. Y equals 3. That's actually the equation of a line. This is a line right here. Notice it doesn't look like this, right? All it has is the b, right? It doesn't have this mx part, which actually means your slope is 0. So this right here is a horizontal line. So how would I graph y equals 3? Because it doesn't look like this, right? How would I graph that? Well, this is saying that y is 3, right? So y is 3 means I go up 3. 1, 2, 3, and I put a dot at 3, right? But my entire line has to be y equals 3. So every point on my line has to have a y coordinate of 3. So it's a horizontal line through 3. So that's your horizontal line. What do you think a vertical line, what do you think the equation of a vertical line looks like? X equals a number, right? So I'm breaking these up into categories here. This is the standard slope-intercept form of a line. Here's the standard form of a horizontal line. And then x equals a number. I'm just going to put x equals c. That example kind of goes with that. Sorry. An example of this would be x is, let's go 2. And then this is your vertical line. How would you graph x equals 2? Well, your x has to be 2, right? So 1, 2, here's your x coordinates this way. So I'll put a dot there, and every point has to have an x coordinate of 2, which means your line has to go vertically like this. Every point on this line, the x coordinate is 2. So just remember that. Y is a constant horizontal, x is a constant vertical. Any other case is going to be this. You're going to have some little pitch to the line, and it'll look like this. All right. What time? I still have a little bit of time. So now what I'd like to do, we're going to kind of come back next time. We're going to graph some lines, but I wanted you to think about two things. I know you've heard these before. Parallel versus perpendicular. Lines. So what does it mean for two lines to be parallel? They'll never touch? Do you all agree with that? That sound reasonable? Okay, so in terms of these scenarios over here, right? If two lines are parallel to one another, they should have the same slope. They should have the same pitch to the line, right? That's what it would mean. And if it's horizontal, then it would be a parallel line would also be horizontal. If it's vertical, it would also be vertical, right? So for parallel lines, we have same slope, but different y-intercepts. So it's like this number on the line is the same, but these numbers on the two lines are different, and that would make them parallel. What if it was the same slope with the same y-intercept? It'd be the same line, right? Okay, you'd be talking about the same line, so that'd be weird. To be like, yeah, that line is two lines. It just wouldn't make sense. All right, now what about perpendicular lines? So the slopes are different, right? They can't be the same or else they would be parallel. Like in terms of visually, what do perpendicular lines? Parallels like this, what do perpendicular do? They cross, like those two cross, right? These two cross. Okay, so not just crossing each other, they cross at a perfect like T, right? Call it like a 90-degree angle. It's like a perfect 90-degree crossing. Agreed with that? So they intersect at a, let's just say at a T, right? Like a T. That's supposed to be a T, like a big old T. Or you could say at 90 degrees if you're familiar with angles, right? 90 degrees. But what about the slopes? Because here the slopes were the same, right? Same slopes. They're reciprocal, almost reciprocals. What is a reciprocal? Before I even, since you brought up the word, you said reciprocal. What is a reciprocal? Like, if I give you a fraction 1/4, what is its reciprocal? 4/1, right? If I give you a fraction 2/3, what is its reciprocal? 3/2. So it's not quite a reciprocal, it's almost. It's the opposite reciprocal, meaning the sign is opposite. So it's the opposite reciprocal slope. Slopes, I'll put. They have opposite reciprocal slopes. Example, if one of the lines had a slope of 3/4, the other line would have to have a slope of -4/3. These just need to be opposite reciprocals of one another, and then they would be perpendicular. Is that fair? Now, again, next class what we're going to do is I'm going to start giving you a bunch of equations, and we're going to start graphing lines and checking to see are they parallel, are they perpendicular, things like that, right? But I'll end today with this idea of parallel lines. Because I initially asked what are two parallel lines, and I heard from over there they don't hit each other, right? They don't intersect. So like let's say you're sitting there on a game show, and you get to that $1 million question at the end, and they say, hey, you know, like, true or false, do parallel lines intersect one another? What would you answer? False? Because I'm asking? Exactly, right? There's got to be some catch to this, right? We all, I think, agree two parallel lines don't intersect one another. That's the way we've been taught, and I'm not disagreeing with that. But I want to explain something, and this is a little historical. Any of you ever take like an art class? Ever like an art history class? Have you ever seen cave drawings? Like drawings done like long time ago? Now, were they good at drawing? They kind of childish. I mean, the good. I mean, like you can tell what it is, but I mean, you would compare it to like elementary school drawings. Yes, stick figures all sideways and stuff. Yes. Okay. Nowadays we can draw, you know, a lot better, right? So do you think that happened just over time, or do you think math has anything to do with it? So let me give you an example. I'm going to draw a street. Okay, I'm going to start showing off my artistic abilities again. The fish, if you weren't impressed by the fish, this is going to do it for you. So here's a street. Do you see it? It's pretty good, right? And here's a couple of buildings on the side. So is it obvious that this is a top view of a street with some buildings on the side? Would you consider that to be a really good drawing? Like, if I asked you to imagine a street with some buildings on the side, is that what you imagine? No, right? Because we're going to be thinking of what our eye would see, right? Now, this street, are they parallel? Are these lines parallel, pretty much? Yes, so they should not intersect. These lines are parallel. They shouldn't intersect. So that's, I'm following all the rules, right? Okay, but if I want to do a good drawing, something that's going to look like what we see, then what I need to do is something completely different than that. And if you've taken any drawing classes or art classes, you'll be familiar with this. What I'm going to do is draw that same thing. Okay, so there's the street, and then here are my buildings. And I'm making a quick drawing here, so. Aye. there. Okay. So this is more like elementary school type drawing, and this is definitely starting to feel more like modern drawing, right? And the key is that I have to break the rules, okay? My parallel lines, in order to trick my eyeball, I actually need to violate the principle of parallel lines that they can't intersect, and I actually need to make them all intersect at the same point. So like all these lines that used to be the road all go to the same point, right? You know, these two lines right here, this and this, they are parallel, but they're actually in this picture, this line and this piece, they're actually going to the same point. We call that the vanishing point. People who have done some art, that's called the vanishing point. So you can start to trick your eyeballs. So if you go back to that, well, I should say this. This right here is called Euclidean geometry. So everything you learn in elementary school, grade school, like high school, middle school, we're basing all our mathematics upon what's called Euclidean geometry. Parallel lines don't ever meet each other, right? But if you want to start stepping away and doing some other things, then you have different types of geometry. This is called perspective. Perspective geometry. So I guess all I'm trying to get you to see here is that the mathematics that we have dealt with our whole lives is just a small fishbowl in terms of the big world of mathematics. Sometimes we have to create entirely new systems of mathematics, like perspective geometry, in order to do other things. Now, we will stay here and we will not leave here. We will always be in this fishbowl in this class, all right? And probably for all the math you ever take. But there are actually classes called non-Euclidean geometry where you learn how you can trick your brain to, see things. And so when we started to realize this, then we started to be able to draw really well. And are there any people who are interested in art? No? Anybody go to like art galleries ever? Has anyone ever seen in an art gallery a piece of tape on the ground that tells you where to stand?
Yes.
Okay, that is because if you try and draw a three-dimensional picture on a flat sheet of paper, if you do that, there is only one single point. There's only one single point where you can stand. You actually have to close one eye, where looking at that three-dimensional picture on that flat sheet of paper would look exactly the way it would look if you were out there like looking at it in the real world. There's only one point. If you move away from that point, up, down, front, back, a little bit, something's going to be distorted. You probably won't notice it, but there's a perfect viewing point, and that's why they have that tape there. It tells you where to look, so everything looks proportioned out correctly. It's all mathematical, though. It's like intersection of spheres, and it's cool, but it's... So, fishbowl, back to that million-dollar question. Do parallel lines intersect? Depends on the geometry, right? Depends on where you are. So, all right, y'all have a good day. I'll see you on Wednesday. Do your homework. I know you'll have questions. Oh, do you want to know what the homework is?
Yeah.
Okay. All right, the homework that you should attempt is now you can finish, hopefully, the problems off 23, 24, and 25. Those are the ones I said go ahead and try them, see how they go. So now finish those. And then page 31, 32, and 33. Those are the ones that and 34, there's some on the back. Those are the ones I expect you to have questions on. It's a lot of questions. Okay? All right. 23, 24, 25. And then 30. Then 31, 32, 33, 34. So 31 through 34 and 23 through 25. We supposed to go to 150? We are, right? Is it 150? 140, okay. I don't know why I keep on thinking.